A football is kicked at an angle theta 37 degree with a velocity of 20 meter per second. Okay, as shown in the figure. Calculate. Okay, first of all, let us label the diagram. It gives us the, okay, this is a projectile motion because kick at an angle. Yeah, got angle. Velocity is 20. Okay, this is 20 meter per second, or in SI unit. Okay, now find the maximum height. Okay, let us just concentrate on part A first. Yeah, let us do part by part. Let's find out the maximum height. So for maximum height, normally refer to the, for height refer to the y displacement. Okay, so for maximum height means over here, over here. So this is the maximum height. This is the maximum height. One thing we know for sure at maximum height, Vy is 0. Okay, and it only has Vx. It only has Vx, which is equal to Ux. At maximum height, Vx equal to Ux. The Vy is 0. It still have velocity. It still have velocity, but only in x component. Okay, we know it only has the x component velocity. Okay, it only has Vx. But Vy is 0. Okay. Now, okay, let's continue. So for part A, okay, let us do it. Okay, we have two components. It's a projectile. This is a projectile question. So it has two components, has x and y component. Okay. Now, talking about acceleration, okay, ax is 0, ay is negative g. Okay. Another thing is, okay, we also know the initial velocity. Initial velocity u. This ux is equal to, we need to find. Okay, maybe we should write over here. Yeah, maybe we should write over here. Put it over here. Yeah, better. Okay, we can refer for all the questions. Ux. Okay, look at the ux. How to find the ux? Make it a little bit further away. Yeah, more space. Yeah. What's the ux? Look at the diagram. Yeah, so we have this one has two components. It has x and y component. So the x is using cosine theta. Okay, and it is positive value because going to the right. Y component is also positive value because going up, and it is using sine theta. See that? Because this one x is cos because adjacent to angle, and y component is using sine because opposite to angle. Okay, and both are positive because going to the right and upward. Okay, now let us write down the information here. So x is positive, and then what is the u? 20. Yeah, 20, and using cosine. You see that? Cosine 37 degree. Yeah, make sure you change your calculator into degree, not radian. Now how about uy? Uy is equal to, okay, also positive because going up, positive, and then it is u 20 sine, using sine theta. So sine 37. So we got it already. Yeah, we got the x and y component velocity. Now we want to find the maximum height. Okay, we know at maximum height, we know about the final velocity over here. Yeah, remember? So this is our final point, is over here. Final point. This here is our initial point. For question A, this is our initial point and this is our final point. So our velocity over here, we also need to write something. So talking about final velocity, so Vx equal to, we don't know, Vy is equal to, at final velocity over here, Vy is 0. Vy is 0 because at maximum height, final velocity V is 0. Okay? I think this Vx equal to Ux lah, because we know x is a constant velocity, isn't it? X is a constant velocity, x component is a constant velocity. So Vx is equal to the Ux, yeah, constant velocity. Now, what we need to find is the maximum height. So maximum height, we use the y components. Okay, we use the y component. So we look at the displacement. So we need the sy. We need to find sy. So the height is about sy. Okay, so can we do just the y component to get the displacement y? Yes, we can, definitely, because we already have 3 values. We have already 3 known values, a, u, and v. Alright, a, u, and v. We can find the 4th unknown by just using the y components. Okay, so let us do only the y components. Yeah, only the y components. Do it over here. Yeah? Part A. Yeah? Only the y component. So what formula can we use? VUAS. VUAS is v square equal to u square plus 2as. So this is the y components. This is all the y component. Understand? These all are the y components. Now, the final vy is 0. Yeah. So our final vy is 0. Okay, so let's continue. Yeah, do the questions. So 0 equal to uy is 20 sine 37, yeah, square. Okay, plus 2, acceleration is negative g. G is 9.81, negative 9.81. A is negative 9.81. So we can find sy. So let's find out the sy over here. Yeah. Okay, so the answer for displacement is 7.38. 7.38 meter. Yeah, that's the answer. Okay. So that is the maximum height. That sy is 7.38 meter. Yeah. Maximum height. Okay, that's sy. Yeah, until when it reaches the maximum height. This is the 7.38 meter. Okay, this is 7.38 meter. That's the maximum height. So now, find the time of travel before the football hits the ground. Okay, now he wants the time of flight, time of travel or time of flight before the football hit where? Hits the ground again. So the hit the ground. Hit at P. Hit over here. Hit the ground. This is the ground. Understand? Hit the just drag it over here. It hit the ground over here. Okay. So time of travel, we want to know how long it takes to hit the ground. So how long is it? Yeah, the whole journey. What's the time for the whole journey? The time for the whole journey before it hit the ground. Okay, so how to find? So right now, okay, question B, we need to find the time of travel before it hit the ground. So how do we do it? Okay, so right now our final point is not at the maximum height anymore. So we can write off this one. It's not over here. Now our final point is, okay, let's simplify our diagram. Now our, okay, this is still our initial point. Okay, now this is our initial point. Maybe I make a highlighter. Okay, this is our initial point, and now this is our final point. Understand? This is our final point over here. This is our final point. Okay, and then this diagram we can find the velocity. We no longer need this value. This value also no need. This is only for maximum height. Okay, rub off again. Okay, we can still use the u and acceleration for question B. Because it's still the same. Okay, however, we don't need to find velocity now. We need to find the time of travel. So how far is it? yeah, it takes to hit the ground. Okay, displacement. Okay, first of all, we look at displacement. Okay, sx means the range. Yeah, this is the initial, this is the final point. So this is the x displacement. X displacement is the range. Okay, and sy is equal to sy is sy is the vertical displacement. This is our initial point and this is our final point. So how initial and final point on the same level? On the same level, so that means the final point is just at the initial point. Yeah, because this, the y component is like, I can draw it up for you. Yeah, this one I transfer over here. Yeah, it's just like, the y displacement is just like the ball is being thrown up and then fall back to the same point again. So the initial and final point, okay, initial and the final point, they are on the same point. It back to the origin. You see that? This is the origin. It back to origin. This is the origin. Okay, it back to origin. So what is the y displacement? Why is the y displacement for this projectile motion? What is the y displacement? The final point is the same as initial point. They're on the same point. So there's no distance between them. So the sy is 0. Sy is 0 meter. Because the ball goes up and hit the ground again. It released from the ground. The initial point is on the ground. The initial point is on the ground, and then it hit the ground again. So the displacement y is 0 because the final point is on the same point as initial point. There's no distance between them, so sy is 0. Don't you go to it goes up and goes down, so got 1 height plus 2 height. So the sy is equal to 2 height, is 2 times the maximum height. Wrong concept. Wrong concept. This is distance. Yeah, wrong concept. This one is about what? This one is a concept of distance. But our concept here, sy, is displacement. Displacement is the shortest distance between initial and final point. It's not the total path taken. If you use the 2h maximum, if you use the goes up and goes down, 1 height plus 2 height, that is the total path taken. Total path taken, but that is not our sy. No. So this is wrong. Yeah, if you put 2 height maximum, it's wrong. Don't go to think, like nothing happened, sy equal to 0, like nothing happened. No. Yeah, this is about displacement. Okay. You put 0, it is already understood that the ball actually goes up and comes back down already. Yeah, it's understood. Yeah, the process has already been done. It's already fly up and fly back down again. Okay, don't you go do silly mistake like 2h maximum. That's wrong. Sy is 0. That's displacement. Yeah, the distance between initial and final point. Okay, blah too much. Now let's find out the time of travel. So it seems that from y component I can find the time, isn't it? Because I have 3 information. I have 1, I have 2, I have 3. I have s, u, a. I can find the time. I can find the time of travel before it hit the ground. The time of travel is the time projectile. The time projectile is the same as the time of the y component. So I can find the time, I can find the time. So time x and the time y. I can find the time y. So let's use the y component and solve it. Y component, so we use the formula s equal to ut plus half at square. Okay, this is actually the y components. Yeah, use the y component, s equal to ut plus half at square. All right. Okay, S. You already have S. Okay, good. So now, S is 0. S is 0 because I fall back to the ground. So displacement 0. So Uy is 20 sine 37. 20 sine 37. Time is, this is what we want to find, the time. Plus half. A is negative G. Negative G is negative 9.81. Okay? So time square. So let's find out the time. Okay, we write over here. This one transfer to the other side, become positive value. So become positive 4.905 t square. And then this one also go to the other side, become negative. What's the 20 sine 37 is equal to go to the other side, become a 12.0363, yeah, 0363, yeah, t, okay, equal to 0. So this one you can factorize out, 4.905 t minus 12.0363, and then the time is equal to 0, and then time, so the other time is 12.0363. Okay, so the answer is 2.45 second. Okay, so you see we've got 2 times here. What it means, here at first, this one 0 second means the time when the ball is being thrown up at 0 second. So it is being on the ground twice, isn't it? It's being on the ground twice. This is the first time on the ground, yeah, when it is being launched. Yeah, when it's being launched. Now 2.45 seconds later, it hit the ground again. Both of this time is when the Sy is equal to 0. Understand? Both of this time, okay, 0 second is when it launched. When it launched, the displacement is 0. Yeah, displacement is 0. And then after that, 2.45 seconds later, it hit the ground. This is the second time. The second time where the Sy is 0 displacement. Okay, so we have 2 times. 2 times that the Y displacement is 0. Okay, so but we choose the time when it hit the ground, this one. Okay, so the answer is 2.45. Is it correct? Yes, it is correct. 2.45 seconds it hit the ground. Okay, so now how far away it hits the ground? Okay, it's getting easier and easier because we have more information now. We already have the time here. How far is it hit the ground? Okay, so let's do the part C. C is how far. How far, that means we need the how far away it hit the ground. So how far means we need to find Sx, and we need to find the range. We need to find the range. How far is it from the initial point it hit the ground? So this is Sx. Okay, so this C condition is still the same as B condition, hit the ground. Yeah, hit the ground. So they have the same final point at hitting the ground. Yeah, question A is at the maximum height, so it's different condition. Question A is the final point at the maximum height. Okay, but question B and C, the final point is at the point hitting the ground. So B and C have the same condition, so we no need to rub anything off. Yeah, we can maintain the same condition. The final point is still on the ground. Okay, so we can, this one we no need to rub anything off. We can use back Sy equal to 0. You see that a point hitting the ground, as the vertical displacement is 0. This one you can maintain, and the time also we can maintain. Yeah, the time here we got just now 2.45 seconds. Just substitute inside 2.45 seconds. This one also 2.45 seconds. You see that 2.45 seconds. 2.45 seconds. So 2.45 seconds. Okay, now okay, I got the 2.45 second here already. Okay, so now is we can find the range. So I can use this information here, 2.45 second, yeah, which I got from the time from y component just now. Okay, we got from the we can use the time here to find the range, to find the x component, to find the range, how far it hit the ground. Okay, let's continue with question C. So question C, we want to find Sx, the range, isn't it? So we can do the x component already because we already have three known values. We have a, we have u, we have time. So we have three known values to find the one unknown. To find the one unknown, which is Sx. So we do the x component. We do the x component. So what is the x component? As we can use the formula s equal to ut plus half a t square. Okay, so this is our no, not y. This is our x component. Our x component here, and then ax is 0. Ax is 0. Ax is 0. So and then yeah, you just substitute. You just substitute here ux, which is 20 cos 37. 20 cos 37, and then the time taken is 2.45. Okay, 2.45. Then we can find a Sx. Let's find out the Sx. Yeah. Okay, so the Sx is 39.13 meter. 39.13 meter. That's our range. That's our range. How far is it? 39.13. Yes, correct. It is 39.13 meter. Yeah, which is the Sx. This is our Sx. Okay, our Sx is 39.13 meter. So actually, we also can write that down already over here. Our range, we got 39.13 meter. So we got, you see, we got so many information already. Later on, if you want to find anything else, very easy. You want to find anything else, very easy. Let's say we want to find velocity, final velocity at this point, at this final point where it hit the ground. Very easy because we have 4 information. We can use whatever formula to find the one unknown Vx, and also we have 4 information in the y component. We can find Vy very easily by using various equations. Okay, so now let's look at the next questions. What is the velocity vector at maximum height? Oh, this one change situation again. Yeah, change situation again. This one is not hitting the ground. You must be careful. What is the acceleration vector at maximum height? So you must be careful. You must be careful. This is about question A is maximum height. Question D is also maximum height. Question E is also maximum height. But for the question B and C is hit the ground. So so you can say this one is together, B and C is together, but A and D and E is together. So they have different conditions. You know that? Do you know that? For B and C, the final point is at the for B and C, the final point is at hit the ground. The final point is over here. Hit the ground. For A and D and E, is at maximum height. That means the final point is over here. The final point is over at the maximum height. So you cannot use this information anymore. Okay, the question doesn't ask us to find the velocity when hit the ground. He didn't ask us to find the velocity at hit the ground. He asked us for question D and E, he asked us to find the velocity at maximum height. So it follow the condition at A. it doesn't follow the condition of B and C. I hope you noticed that. Yeah. So for this one, I have to draw the diagram again. Okay, I already duplicate the diagram here. I put into here. Okay, so this is for this one just now. This one is for condition. This one is for condition hit the ground. So this is for B and C. Yeah, for B and C. The final point is over here. But for A and D and E, A and D and E, if for the A and D and E, not F, E. So A and D and E is at maximum height. You want to know the final point is at maximum height. For B and C, the final point is hit the ground. But for A and D and E, the final point is at maximum height. Okay, so it's over here, the final point. Okay, this is still the initial point. So yeah, so over here and here. Yeah, the ball now is over here. Okay, so for this one, okay, but we this one we still can maintain the the top one. Just copy again. Yeah, put it over here. Yeah, this one can drop off. Yeah, so this one is still the same. Okay, the acceleration for x is 0, acceleration in y negative g. The initial velocity ux and uy you can use back. Now we want to find velocity. The question asks for velocity vector at the maximum height. So at the maximum height, we want to find the velocity. We want to find this velocity, final velocity here. Okay, so how? At maximum height. This is at the maximum height. Okay, at maximum height. At maximum height, one thing we know about final velocity, this final velocity is, we know that the Vy is 0. The y component velocity is 0. It only has Vx. Okay. So velocity. Okay. So we have Vx and Vy at the maximum height. Our Vy is 0. Just put Vy 0. But how about Vx? Vx, we don't know. Yeah. What is our Vx? Okay. How? So very simple. This one although have two information, but it's enough for us to find Vx. So how? We know it is constant velocity, isn't it? Okay. So this is for question D. Yeah. So for question D, we just use the x component. Okay, because we want to find Vx. So what is Vx? We just use the formula V equal to U plus AT. So you see, this all is x component. But because AX 0, so Vx equal to Ux. Because S component is constant velocity. S component is always constant velocity. So Vx, the final velocity, equal to the initial velocity in x component. Okay. So we got already. It is also 20 cos 37, which is 20 cos 37, which is 15.97 meter per second. We got the velocity in the x component. Okay, this is the Vx. So Vy is 0, Vx is this one. So the final velocity, the velocity at over here is just Pythagoras theorem, Vx square plus Vy square. But Vy is 0. You see that? Vy is 0. V is equal to Vx because Vy is 0. So Vx square root, you get Vx. V is Vx, which is also 15.97 meter per second. And then you can say the direction to the right. Direction to the right, because why? Direction to the right because it has no y component. The velocity only has x component, so it's to the right. Is that answer correct? 15.97. Yeah, to the right. Velocity vector. Yeah, that's correct. Vx equal to 15.97 meter per second. That's correct. Vy is 0. Okay. Now, next is what is the acceleration vector? What is the acceleration vector at maximum height? Acceleration vector at maximum height. You know, this one, acceleration is the same for the whole projectile. I just want to write over here. It is the same for whole projectile. For whole projectile. For the whole projectile motion, the ax is always 0. For the whole projectile, the ax is always 0. Ay is always negative g. I think I already showed you an animation which I made myself regarding the acceleration vector. Yeah, maybe I show you again. Okay, now here's the animation to show that acceleration for the whole projectile is always constant and directing downwards. Ax is always 0, but Ay is always negative g. Look at this animation again. This is the one, yeah? Hold on a second. Yeah, look at this animation, yeah? Now you see, look at the acceleration vector. This is acceleration vector. Acceleration is always constant, directing downward. Ax 0, Ay negative g. You see, the yellow arrow is always constant, even at the maximum height. It's still directing downward. You see that? You see the vector? Even at the maximum height, the acceleration still downward. You see the yellow line never change. The yellow line never change. You see that? The yellow line never change. Okay. So I hope you are clear. The acceleration for the whole projectile is always Ay equal to negative g for the whole projectile. You see, for the whole projectile, you see that? Yeah. See that? See, for the whole projectile, it's always like that. Always downward. Okay. That's it. Okay. So the question asks for what is the acceleration vector at the maximum height. So what is the acceleration of the maximum height? Remember the yellow line? It is downward. Ay equal to negative g. That's it. Ax is equal to 0. Yeah. The acceleration at any parts is always downward. It's always downward like that. Yeah. So so we can say acceleration vector at maximum height is okay, where do I write? Yeah, this E. Yeah. So so for E, the answer is Ay equal to negative g. Yeah. You can write it as you must write Ax first. Yeah. Ax is equal to 0. Ay is negative g, or you can write is as negative 9.81 meter per second square. Ax is 0 meter per second square. Ay is negative g, negative 9.81 meter per second square. So is it correct? Yes, Ax 0, Ay negative 9.81 meter per second square. That's it. Yeah, or you can write it directing downwards. The direction is downwards all the time. Yeah, must write, because vector you must give direction also. Give magnitude and also directions. Okay, so that's it for all the questions. Okay, hope you understand and enjoy my video. Please share my videos and subscribe my video if you like. Okay, and you also can share to your friends. Yeah, invite more friends to watch my videos, because this is a beneficial videos for all. Okay, see you again. Bye.